Hello and welcome to CB Astronomy. I'm Chris and as always I'm your host. A few eagle-eyed people might spot that I'm back in my usual setup. Unfortunately it was a bit unavailable to me for my last video, and thank you to my buddy who let me use his setup. But yeah, I'm back. So today's video is a quick rundown of 10 misconceptions that have bugged me over the years and that I just need to get this off my chest. So, hope you enjoy. Alright, so number 10. This is possibly the most vexing at the moment. The misconception that the Earth is flat. Right. The Earth is not flat. It's spherical in nature, as are most things in the universe. If you don't believe me, there's a live feed on the International Space Station that you can Google and watch as it orbits the Earth, and you can sit there and watch it all day long as it goes round and round over and over, and you can draw your own conclusions from that, aside from the enormous mountain of proof that the Earth is spherical. So yeah, that's all I'm saying on that. Just stop saying the Earth is flat. Thank you. Seriously. Right, number 9. The young universe. So I've seen a lot of people saying this, and to be honest I didn't think I was going to come across this when I was looking at common misconceptions, but a lot of people seem to think that the universe itself is only a couple of thousand years old. Now this just isn't true in the slightest, and one of the reasons for that is the speed of light is constant everywhere in the universe. It's roughly 3 by 10 to the 8 meters per second. And since we can calculate the distances between the Earth and distant stars and other galaxies, we can determine how long it takes light from a source to get to us. And we have seen galaxies that are billions and billions of light years away from us. And since we can calculate how long it's going to take for the light from a distant galaxy to get to us, we can determine that the universe is a lot older than a couple of thousand years old. Yeah, that's all I'm saying about that. Two quick ones. Yeah, number 8. And this one, I remember hearing when I was younger, like in early school, people were saying this when we were first learning about the planets and the stars, and at the time, yeah, I didn't have anything conclusive to say back to it, so I just had to take it on board. But I've had people saying it to me in recent years, and I've told them otherwise, and I think most of the people who've said it to me believe me. But the misconception that if the Earth was 1 inch closer to the sun, it would be a fireball or a lava world or whatever phrase you'd like to use for uninhabitable by fire, and if it was 1 inch further away it would just be a big ball of ice. So as I got older and started learning about orbits, I was quite shocked to find that orbits are rarely perfectly circular. So the Earth's orbit around the sun is actually an ellipse, so it's slightly egg-shaped. So that means that the distance is never constant. It's always changing as it's orbiting around. So because of the nature of ellipses, it's always changing. And when scientists refer to the distance between the Earth and the Sun, they're referring to the average distance, which is about 149.6 million kilometers. So yeah, that's another misconception, correct. Yeah, number 7. So this is just two words being similar but meaning totally different things, and it's the misconception that astronomy is equal to astrology. Like, people seem to think that they're the same thing, and like, you know, so, like particularly you can call, and if you're watching this, I know you just say the wrong word to one, but some people do really think that they are the same thing and they're the furthest things from each other. So astrology is the study of the motion and planets of the motion and position of the planets and stars, and the belief that where they are will somehow influence your personality or your life. Which, like, I'm all for people believing what they want to believe, but I think that is just preposterous and arrogant, if anything. But and astronomy is the actual science and the study of the stars, with subject to scrutiny and peer review. And if something is tested and is proven wrong, that's gone, that's scrapped, and you move on to your next idea. So yeah, that's the two of them done. What's next? Number 6. Sorry, just finding where I have it written. So the misconception that there's no gravity in space. Now, in fairness, this isn't too much of a leap to make, because when we see footage from the International Space Station and that, everything is floating, the people, the tools, and like everything is just floating around having a good time. So it isn't too big of a leap to say, oh, they're floating because there's no downward force pulling them to the ground. And I made the mistake myself. But in reality, the astronauts and the space station itself are in a constant state of free fall. So what that means is how this works. So really they should be falling straight back down to Earth, but because the station has so much horizontal velocity, it's the planet rotating, the ground actually curves away from you faster than you can fall, and that's why the space station stays in orbit. So your horizontal momentum is carrying you around at a faster rate than the Earth is turning, and that's why you don't plummet back to Earth. So number 5. Sorry, one sec. Oh yeah, the dreaded one. Pluto, planet or not? I have to say no, and I know, Gary in particular, you're not going to be happy about this, but it's not a planet. I'm very sorry. The reason it's not a planet is because the International Astronomical Association or Union. International Astronomical Union. Apologies. So a planet is defined by 3 different sets of criteria. It has to orbit the sun, which Pluto does, but in a weird way. It's at a very strange tilt to the rest of the planets, but it orbits the sun all the same, so you can't declassify it for that reason. It needs sufficient mass to assume hydrostatic equilibrium, which means it needs to get enough mass on it that it forms roughly a sphere. And number 3 is that it has to have completely cleared its local neighborhood. Now what that means is it needs to be the dominant source of gravitational influence in the region. And much like a couple of planets you've never heard of, like Ceres and Vesta, which are now declassified as asteroids, that's what the same thing is happening with Pluto. It's put in a different category because, fair enough, when it was first discovered, or maths and technology wasn't that great, but upon observation, resizing had to be done, and the estimate size kept on going down and down and down, and a lot more objects like Pluto were found nearby. So it wouldn't be fair to call Pluto a planet anymore. Right. Number 3. Sorry. Yeah. So, although this has been fairly cleared up, the mistake was made initially by Star Wars, saying that the Millennium Falcon completed the Kessel Run in 14 parsecs, I think. But so I know a lot of people have pointed out that a parsec is a unit of distance and not of time, but just a lot of people might not know what a parsec is. So a parsec is used to describe a really, really big distance. So instead of saying like billions and billions of light years, it just sounds like a massive number. You can reduce it down to a slightly smaller, more manageable number. But so I have it in there. A parsec is 3.26 light years, or 3.057 by 10 to the 16 meters. So it's a really, really big distance. But in case you knew that parsec was a distance but didn't know exactly how far, whether it was big or small, now you do. So, and number 2, Mercury, is it the hottest planet? No. So, it being the closest planet to the Sun, it's not logical to assume that it would be the hottest. But the thing is, Mercury doesn't have much of an atmosphere to actually trap the heat. So, a lot of the heat that Mercury gets is just radiated back out into space. And that's why it is not the hottest planet. Now, the temperatures on Mercury, like, you wouldn't want a holiday there. It can range from minus 173 degrees Celsius to 427 degrees Celsius. So it's a massive range. But the hottest planet is in fact Venus. Now, Venus has a really thick atmosphere of carbon dioxide and is often used as a worst case scenario for Earth if the CO2 levels reach a critical level. But so carbon dioxide is a heat trapping element, and when your atmosphere composes mostly of it, beam of light will come in and it'll just keep on getting reflected down onto the surface. It doesn't escape, and that's why Venus is the hottest planet at 462 degrees Celsius. Yeah, now that's cleared up. So where is my number 1? Oh yeah, the reason I kept this one for last is because it was a bit of a mind blower for me, and I found it a bit difficult to get my head around it initially. So, nothing can travel faster than light. Right, the reason that this is a misconception that I've thrown it in here is because it's more of a play on words than anything else. Because especially in the early days of the universe, galaxies were moving away from each other at a faster than light speed, and we couldn't figure out why. It wasn't until someone made the connection, and the words literally nothing can move faster than light. Literally nothing. So the galaxies can't move away from each other at a faster rate, but the space between the two galaxies itself can do whatever it wants. That can expand. So when you say nothing can move faster than light, you're literally saying the empty space between the two galaxies can expand out a lot further, or a lot faster than the speed of light if it wants to. So that's my 10 misconceptions. I hope you enjoyed them. Usual stuff will be in the description, the Instagram and Twitter. A few subscribe buttons maybe around here or over there, as well as the previous videos. If you haven't watched them, go back and give them a watch. Really appreciate it. Thanks for listening, thanks for watching, and see you later.